Hey, so let's talk about something you're feeling right now, but probably not thinking about. It's the force that's keeping you in your seat, but it also holds some of the universe's biggest, wildest secrets. Yep, we're talking about gravity. And believe me, its story is way cooler and weirder than you think.
I mean, just think about that for a second. It's the reason you don't just float away, but it's also the cosmic glue holding together stars, planets, and yeah, entire galaxies. So, how on earth did we figure out the rules to this invisible, universe spanning power? Well, the story of how we understand gravity is really a tale of two absolute geniuses. They completely flipped our view of the universe upside down. It's a journey that takes us from simple falling apples all the way to bending the very fabric of reality. For thousands of years, we were pretty much just guessing. You had Aristotle, who thought things fell simply because they wanted to be at the center of everything. Then Galileo comes along and starts doing real experiments, proving, hey, wait a minute, heavy or light, things fall at the same speed. But the first real game changer? That was Isaac Newton in 1687. This was Newton's light bulb moment. He realized that the same force that pulls an apple from a tree to the ground is the exact same force that keeps the moon circling the Earth. It was universal. All of a sudden, the rules up in the heavens were the same rules down here on Earth. Mind-blowing for the time. Here's the crazy thing, though. For all its power, holding entire solar systems together, gravity has a secret. It's actually, and this is going to sound weird, the weakest force in the universe. By a lot. Think about it. A dinky little fridge magnet can defy the pull of the entire Earth just to hold up your shopping list. And if you want to see the numbers, it gets even crazier. The electric force pushing two electrons apart is, well, it's a number with 42 zeros after it, times stronger than gravity pulling them together. It's just absurdly weak. The only reason gravity wins on the cosmic scale is because big things like planets and stars are electrically neutral, so gravity's tiny pull can add up and take over. Okay, so Newton's law was a smash hit. I mean, predicted everything. Planet orbits, cannonballs, tides. It worked perfectly for over 200 years. But as we got better at looking at the universe, we found a tiny, tiny little flaw in the theory. And the problem child was Mercury. Its orbit around the sun wasn't quite stable, it was wobbling. The closest point of its orbit was shifting just a little bit every century, about 43 arcseconds. That's a super, super tiny fraction of a degree. It's almost nothing. But in physics, almost nothing can mean everything is wrong. So that tiny wobble set the stage for our next genius, Albert Einstein. He steps up and asks a question that changes everything. What if gravity isn't a force pulling things at all? What if it's something way stranger? What if it's the actual shape of the universe? You see, Newton imagined space as this big, empty, static stage where objects just pull on each other. But Einstein saw space and time as being woven together, like a fabric. He called it space-time, and he said that heavy things, like a planet or a star, literally bend and warp that fabric, kind of like a bowling ball on a trampoline. So the Earth isn't being pulled by the sun, it's just rolling along the curve in space-time that the sun creates. And the idea that sparked all of this was what Einstein himself called the happiest thought of his life. He imagined a person in a falling elevator. For that person, they'd be weightless. Gravity would just disappear. So he realized that feeling the pull of gravity and feeling acceleration are basically the same thing. They're equivalent. That was the key. And Einstein's new theory, general relativity, wasn't just a tiny fix. Oh no. It opened up a whole new universe of bizarre and incredible things that Newton's laws couldn't even begin to imagine. So that weird wobble in Mercury's orbit, Einstein's theory nailed it perfectly. It also predicted that giant objects can literally bend the path of light, creating these cosmic mirages. And it predicted black holes, places where space-time is warped so badly that they become a one-way trip. And maybe coolest of all, it predicted that when huge things like black holes collide, they send out ripples in space-time itself, gravitational waves. And guess what? We finally detected them in 2015. Incredible. But even with Einstein's incredible insights, the story is far from over. In fact, his theory just showed us how much we still don't know, opening up even deeper, darker mysteries that we're wrestling with right now. For instance, when we look at galaxies, they're spinning way too fast. They should just fly apart. It seems like the gravity of some invisible stuff, which we've nicknamed dark matter, is holding them together. Then there's the fact that the universe isn't just expanding, it's speeding up. Something we call dark energy seems to be pushing everything apart. And get this, these two mysterious things make up 95% of the entire universe. We basically don't know what most of the universe is made of. Okay, so we've been way out in the cosmos dealing with black holes and dark energy. Let's bring it all the way back down to Earth. I've got a challenge for you, a way for you to be a scientist for a day and test one of the first big ideas about gravity right in your own home. It's called the Galileo Drop. All you need to do is find two things with different weights, but about the same size, to reduce air resistance. A golf ball and a marble work great. Just hold them at the same height, let them go at the exact same time, and watch. If Galileo was right, they should land at the exact same moment. Pretty cool, right? Go ahead and give it a shot. So, from a simple apple falling from a tree to the bending of space-time and the hunt for dark matter, gravity really does shape our entire universe. It's the biggest lightweight we know, somehow both incredibly weak and unbelievably powerful. And the biggest question is still out there. What's the next great mystery it's going to help us unlock? Thanks for joining me on this one.